Welcome to Mrs. Kate's YouTube channel. In this lecture, we will be talking about air pollution. To start things off, I want you to play an educated guessing game. In your head, make a short list. Which cities in the world have the worst air quality? In other words, which cities have the most air pollution? Take a moment to think about this. Here is the actual list from Science Time in 2011. Were these the cities you expected to be on the list? Probably not. Most of them you've never heard of. But why do you think these cities have so much air pollution? You will notice that all of these cities have the following characteristics. They're in developing countries. These are places with dirtier cars, more factories, and fewer regulations. Government laws aren't stopping pollution here. These are also smaller cities, not your major megalopolises like Beijing, Bangkok, or Mexico City. In major cities, factories may just constitute one small part of the city. There are other areas for homes and businesses, and even usually some green space. But in small cities like these, there's a focus on industry. Factories take up most of the space. Finally, these are places where there's a significant amount of poverty. Residents here burn heavy, polluting fuel for heat and energy, including firewood and dung. As we learn about air pollution, there are a few key objectives I would like you to keep in mind. First, by the end of this lesson, you will be able to identify the 4 results of global air pollution: smog, acid rain, ozone layer depletion, and global warming. Second, you will be able to describe what causes these events and what some of the negative consequences are for people and the environment. And finally, you will be able to compare and contrast the Montreal Protocol and the Kyoto Protocol. As you compare them, you will see why one succeeded while the other one did not. First, let's talk about smog. What is smog? Smog is a word that comes from the combination of smoke and fog. It is characterized by heavy air pollution that can persist for days. This occurs especially in warm, humid climates. In these areas, smog will settle in the valleys between mountains and stay for days and days. It is primarily caused by emissions from cars and industrial factories. There are several negative impacts of smog. When smog is at high levels, this can result in school and factory closures. You will also see increased rates of illness. This has a high economic cost in terms of the cost of treatment, loss of work, and death. The World Health Organization estimates that 2 million people every year die prematurely from air pollution. This is also an issue of environmental injustice. Illness from smog disproportionately affects the poor. This is because if you're wealthy, you can afford to live in a place where smog does not accumulate as much. You can live at the top of the mountain instead of in the valley. If you're wealthy, you can also afford better ventilation systems for your home and your car. And you're not outside taking public transportation or riding on a motorcycle. You can also afford healthcare costs to treat any medical problems associated with air pollution. One way to measure smog is to use the Air Quality Index ratings. This metric is used by government agencies worldwide to communicate how polluted the air currently is or is forecasted to become. These index ratings relate directly to the likelihood of adverse health effects from air pollution. In your workbook, you read about one particular adverse health effect, cancer. The UN now estimates that air pollution is one of the leading causes of lung cancer worldwide. Using the Air Quality Index ratings, we can see that the higher the rating, the more people will develop respiratory diseases. Here's what the Air Quality Index rating system looks like. Take a moment to look at this chart. As you can see, the index here provides a number from 1 to 10. This indicates the level of health risk associated with the air quality. It specifies the risk for any at-risk persons, such as young children or the elderly, as well as for the general population. So between 1 and 3 is low risk. Even at-risk people, such as children and the elderly, can be comfortable enjoying their usual outdoor activities. As you move down the chart, though, you'll see that people are encouraged to limit their activities based on the quality of air outside. When the health risk is high or very high, even healthy individuals are advised to stay inside. Here is a picture of smog in Beijing. You can see what the air should normally look like and what it actually looks like with all the smog. Worldwide, China is known for having terrible air quality in its large cities. Over the summer, a colleague of mine who was living in Shanghai told me that the Chinese are now experiencing a reduction of about 5 years of average life expectancy because of the pollution. The pollution is particularly dangerous for children who are struggling with problems like asthma and bronchitis. Another one of the problems in China is that the government doesn't publicize its air quality index ratings accurately. For example, on the radio in Beijing, you may hear announcements that the health risks are low or moderate, but this is not always truthful. The U.S. Department of State, at its embassy, keeps similar records on the air quality, and their measurements show ratings at high or very high levels of health risk. Most Chinese have figured this out, though. When you look out the window and you see smog like this, it doesn't take a genius to conclude that you shouldn't let your kids go outside and play soccer. Still, it does mean that the Chinese have not been implementing the laws and regulations that would be necessary to decrease this type of air pollution. Our second topic is acid rain. I won't spend too much time on this topic since I'm sure you've discussed it in your science classes. Your reading also highlights some of the key points about acid rain. So what is acid rain? Acid rain is precipitation that is unusually acidic. It is caused by certain pollutants, specifically sulfur dioxide and nitrogen oxides. When these pollutants interact with particles in the atmosphere, the process produces acid rain. As your reading describes, there are two types of acid rain, wet and dry. Wet includes things like rain, snow, and fog. Dry are particles that fall back down to earth and are blown around by the wind, and people can breathe these in. Both are problematic for the environment, and you can read more about this in the readings in your workbook. There are several negative health impacts from acid rain, and impacts overall for the environment. One is that it destroys property, particularly historic buildings. You can see in this image the effect of acid rain on a cathedral in Europe. Notice how the stone is worn away? This is because of acid rain. Another negative effect is the harm to land and water-based plants. Trees, phytoplankton, and fish all suffer when exposed to acidic rain and water. Here you can see the effect of acid rain on a forest. Notice how damaged the trees are. Finally, acid rain has dry particles that remain in the air and can be breathed in by people. This can cause respiratory illnesses like asthma and bronchitis. As we talked about already, there are issues like this, and there are also issues of environmental justice. The negative effects will disproportionately affect the poor, who cannot afford high-quality ventilation systems and medical treatment. Our third topic is the ozone layer. When I teach climate change to my 7th graders, there's always a lot of confusion about the ozone layer. So just to clear things up, I want to make a distinction between these two problems. The problem of the ozone layer is fundamentally different and separate from global warming. Of course, they're both related to air pollution, but as you'll see, the nature of these two problems is very different. They're caused by different things. So this has resulted in differences in how the problems have been handled by the international community. What is the ozone layer? The ozone layer is a layer in Earth's atmosphere that contains relatively high amounts of ozone. One of the great benefits of the ozone layer is that it absorbs 97 to 99% of the sun's medium frequency ultraviolet or UV light. Since UV light is damaging to life on Earth, the ozone layer protects us. You hear about UVA and UVB rays because they're known to cause cancer. The ozone layer acts like sunblock, protecting us from these rays. Unfortunately, human activity has damaged our ozone layer. We've poked holes in it. We've damaged it using chlorofluorocarbons, or CFCs. These are chemicals that were commonly used in refrigerators and air conditioners until the 1970s. They're also emitted by paints, solvents, pesticides, gasoline, and other petroleum-based chemicals. Just like acetone dissolves your nail polish, when released into the air, CFCs dissolve ozone. This makes the layer of ozone thinner, and in some places it has created holes. Here you can see projections from NASA, the United States National Aeronautics and Space Agency. The colors represent the concentration of ozone in our stratosphere. This image shows what would have happened if chlorofluorocarbons had not been banned. Here you can see 1974, 1994, 2009, 2020, 2040, 2060. As you can see, the ozone is getting less and less. NASA projected that by 2060, we would have very little ozone remaining, and this would have created significant problems for life on Earth. Luckily, countries figured this out and started to ban the use of CFCs. And finally, we can point to some examples of international cooperation. The international community was actually able to do something to solve this major global issue. So in 1978, countries like the US, Canada, and Norway banned certain products containing CFCs, particularly aerosol sprays. This was the first step. Not much happened for a few years, but then, in 1985, scientists discovered a huge ozone hole over Antarctica. Remember those colors from the NASA projections? You can see how little ozone there is over Antarctica. This led a lot of other countries to panic. There was a huge hole over Antarctica and they could see it. There was real scientific evidence that ozone depletion was a major problem. So in 1987, countries around the world got together to negotiate what became known as the Montreal Protocol. This protocol established a worldwide ban on substances that deplete the ozone layer, namely CFCs. Countries around the world got on board, and by 1996, CFC use was completely phased out. The Montreal Protocol was founded on the belief that if everybody followed this agreement, the ozone layer would recover by 2050. Since 1987, there are 197 countries that have signed on. And because so many countries signed on and actually implemented this ban, the ozone layer is really likely to recover. Because of its widespread adoption and implementation, this treaty has been hailed by the United Nations and the international community as an excellent example of international cooperation. Kofi Annan, the former Secretary General of the United Nations, called it perhaps the single most successful international agreement in history. So why did the Montreal Protocol succeed? First, there was conclusive evidence of the problem. You saw the image of the ozone layer above Antarctica. Wasn't it striking? If you were a government leader, wouldn't you be convinced by that evidence? Because of the hard evidence, there was political will among world leaders to solve this problem. At the time, major governments around the world had more moderate leaders. In the United States, we had Jimmy Carter, who was a strong environmentalist, and then Ronald Reagan, who wasn't too bad for the environment. Congress was also on board. Third, in many cases, the technology for reasonable substitutes was there. It was already available. And because the technology was in place, there were affordable substitutes available so that CFCs could be phased out. The ban did not cause a significantly negative economic impact. You didn't have to make a big trade-off. Countries like India and China were in the earlier phases of development, and it was easier for them to make the switch. Finally, there was money to make the change. The major powers of the world set up a multilateral fund to assist developing countries in making the switch. This made it possible for all countries around the world to sign on. It helped that organizations like the World Bank, the UNEP, and the UNDP helped to implement this. So there you have it. Yay! Finally, evidence that solid international cooperation is really possible. Now let's look at our fourth and final topic, global warming. As you've probably anticipated, solutions to the problem of global warming have not been so easy. I'm not going to bore you with a further description about what global warming is. I think you've covered that in your science classes. For this lecture, let's presume to accept the evidence that climate change seems to be happening and that this shift in climate is the result of human activity. Let's also recognize that global warming is a significant global issue for reasons that we've discussed in class. So since we can skip all that, let's go straight to the solutions. How are we trying to solve global warming? The major legislation that has been put in place by the international community is the Kyoto Protocol. Like the Montreal Protocol, this was another international agreement signed to improve the environment. But instead of focusing on CFCs, it focused on greenhouse gases. The protocol was initiated about a decade after the Montreal Protocol and was initially begun in 1997. The goal of the treaty is to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. Anthropogenic means caused by humans. So essentially, the goal is to prevent people from burning so many fossil fuels that it's messing up our planet. At the heart of the protocol is the expectation that countries make binding agreements to reduce greenhouse gas emissions. Each country had to make certain pledges to reduce their emissions. Some countries, like the United States and the European Union, were bound legally and would incur stiff penalties if they failed to meet their targets. Other countries, particularly developing countries, were not given specific legal targets, but were encouraged to reduce their emissions. Now, when I say developing countries, countries like India and China, who are large polluters of greenhouse gases, were also included in this, and this became a problem later. In order to make this whole thing work, a complex system of carbon credits called cap and trade was established. So, has the Kyoto Protocol been successful? Not really. At least not to the extent that the Montreal Protocol was successful. An optimist might say that the international community is still working out the kinks. And normally I'm an optimist, but not in this situation. Here I'm a pessimist. I think the Kyoto Protocol has largely been a failure. So why is the Kyoto Protocol failing? Let's put this within the context of the Montreal Protocol, because I think it helps to compare these two situations. So as we saw, the Montreal Protocol had significant conclusive evidence that CFCs were depleting the ozone layer, and they saw the ozone hole over Antarctica. However, with climate change, for a long time, the evidence has been inconclusive. People are failing to accept that climate change was really happening. I've had many conversations with my own grandfather about this. He still swears, now, today, in 2013, he still swears that our changing climate is a normal, natural shift in Earth's temperatures. Since it's normal, he doesn't think we should do anything about it. He's not the easiest guy to talk to, my grandfather. Because of the lack of evidence, there has not been very much political will. In the decades since the Montreal Protocol, the politics within major governments has changed. In the US, we had Bill Clinton in the White House. He was a Democrat who wanted to sign on to the treaty. But really, it's the American Congress that makes that decision, and Congress at the time was very conservative. The leader in Congress, Newt Gingrich, is very much like my grandfather. I think he's kind of an idiot, but he held a lot of political power and was very influential. So at the time, Congress refused to ratify the agreement. This meant that the U.S. had signed the treaty in name, but wasn't actually going to fulfill its promises. Stuff like this happened all over the world, and in some, it means that world leaders right now are being less effective. Leaders like Gingrich also had some practical concerns. One was that in 1997, the technology for substitutions wasn't there. For companies to stop burning fossil fuels, this would have a significant impact on the country. Energy substitutions were still largely unaffordable for your average person in the developed world. Things like solar and wind energy and even hybrid cars, the technology wasn't there, and in many cases it's still not there. This was not only true in America, but all over the developed world. So for this reason, many signatories are not actively participating. The US government determined that the treaty was largely symbolic. India and China weren't required to establish targets. Other countries really tried to reduce their greenhouse gas emissions, but countries like Canada, Japan, Russia, they actually found that they couldn't do it. So instead of incurring the penalties, they just quit. They abandoned ship in 2011. So we've looked at data on greenhouse gas emissions and the ecological footprint and everything. And in class, we've talked about the difference between developed countries and developing countries in terms of their ecological footprint. So without the US, China, India, Russia, Canada, and Japan, these huge polluters, if they don't sign on to this treaty, are you really going to be able to make a difference? Still, what can we learn from all this? Surely we're not going to give up trying to solve our global environmental issues. But there are a few things to consider from a practical point of view. I would say, to have success when executing a large-scale environmental treaty, it's best to consider a few things. First, it's best to have strong, conclusive evidence. This can help you create political will that's necessary to make the changes you need. It also helps to have good technology so that you can make the economic impact minimal. When these criteria are met, you are likely to get large-scale buy-in from the international community. When everybody's on board, this can lead to real change. I hope this lecture has been helpful and informative. If you have questions, please bring them to class. Thank you for watching Mrs. Kate's YouTube channel, and thank you for doing your homework.